Hello everyone, my name is Ajay and today we are going to talk about virtual private network on AWS. So we call it Amazon VPC and that basically enables you to launch AWS resources into a virtual network that you define. So it's a kind of setting up a boundary which is start from CIDR or CIDR. Then you are going to have multiple subnets. Those are going to be the part of that particular boundary. No additional charges for creating VPCs. A virtual private cloud is a virtual network dedicated for your AWS account. And we normally use private IP ranges defined under 1918 RFC. And these IPs are going to be reusable. So for example, you can use one series from these RFC 1918, and other customers, they can also reuse the same range. Every account comes with a default VPC. Those are not created by you. It comes by default, created by AWS, and has a default subnet in each availability zone. And we will see when we are going to take a look on the lab. These AWS VPCs can operate in dual stack mode. What it means, you can use IPv4, you can use IPv6. You can also bring your public ranges from IPv4, IPv6 that we called bring your own IP. VPC is per reason that there's a limit which is going to be 5 by default. However, you can increase it to 100. Per subnet, I'm sorry, per VPC, a limit for subnets are going to be 200. So you can create 200 subnets in each VPC. And you can also introduce 5 CIDR ranges. When we define the CIDR range, it can be somewhere between /16 to /28. So /16 is going to give you the host range of 65,536 IP addresses. And in /28, you are going to get 16 IP addresses. So while defining the CIDR, you need to understand your network requirement, how many hosts, how many subnets you are going to launch. Based on that, you can decide what is going to be the boundary. After you have created the VPC, you can also associate secondary CIDR blocks. As I mentioned in my previous slide, you can attach up to 5 CIDR blocks to one VPC. So let's take a look how it looks like. So on top of that, you are going to have a region. Under the region, you are going to have the availability zone. And this VPC, what you create, is attached to a region. And under the subnets, what you're going to create, those subnets are going to attach to availability zone. So here you can see I have taken a primary range, which is going to be 10.0.0/16, and secondary CIDR range is going to be 10.2.0.0/16. So how we can allocate the subnets? My first subnet, which I want 10.0.0/17, that should be part of one availability zone. Second subnet 128.0.0/17, that's going to be second availability zone. And my third subnet, which I have taken it from the secondary CIDR range, that is going to be part of the third availability zone. And how these nodes talk to each other? So let's try to understand. My node 1, node 2, node 3, node 4. That is physical nodes. On top of that, providers, they are going to run the hypervisor. And under that hypervisor, you are going to have your VMs running. And these VMs can talk to each other using the overlay network, which can be VXLAN, it can be NVGRE kind of thing. So you are going to have a network. which is defined by you. And physically, how they are connected, we don't know. But for example, if I have my VM1 here and my VM2 sitting on the node 3, they can talk to each other over the overlay network. This is another slide just to make you understand how the concept looks like. So first layer, you're going to have the region where your VPC is going to be attached. Once you create the VPC, you're going to have multiple availability zones that you can check on the portal. How many availability zones are there for that particular region where you want to launch your workload? Under that availability zone, your subnets are going to be attached. So this is my first subnet. I want to attach it to AG1. This is my second subnet. I want to attach it to the AG2. When it comes to application design on the AWS, if you talk about the three-tier architecture, so you want to put some front ends, those are going to be the public facing. So for that, you should create a subnet, which is going to be the public. Then for the database and the application, you are going to have another subnet, which is going to private. So hosts sitting here in the private subnet, they will not have direct access for internet. Similarly, you might want to launch multiple applications on AWS. So this is design might look like for the AZ1, and you can also replicate the same thing on AG2 as well. Let's also try to understand what it means by public and private subnet. So by definition, if I say this is my public subnet, it means it has some sort of internet connectivity. It has nothing to do with the tag. There's no tag as such available the moment I give the name public to the subnet is going to make all the resources available to the internet. No, it doesn't work like that. So anytime when you create your subnets, those are going to be private in nature. And the moment you define a route towards internet gateway, that makes all these resources to be available to the internet. So when I say this is my public subnet, it means I'm going to have one route towards IGW. In my private subnet, since I don't need any sort of internet connectivity to these resources, they might be kind of the database servers, so those should be sitting in very secure environment. So I'm not going to have any route towards internet. Let's take a look. How do we create virtual private cloud? So on your main portal, type VPC in the search bar, and then you're going to see the service. Click on that. As I mentioned earlier, there's a one VPC which you're going to see it comes as default. So after clicking on the VPC services, I can see there is one VPC available, and there are 6 subnets are also available. And there's one route table which is available, and there's one internet gateway as well. So all these components comes by default. Once you click on the launch wizard or maybe create new VPC, you're going to see these type of options. So first option is VPC only and VPC with subnets. That is default option. And it is also going to tell you how these components will be tied to each other, which you can visualize. Now what you need to do, you need to give a name for your VPC. You need to define your CIDR block 10.0.0.0/16, which I have chosen. I don't want to go for IPv6, so we will only focus on v4. My tenancy is going to be the default, though when you click on this drop down, you can see the option for dedicated one. Availability zones. How many availability zones you want to choose? This region by default it gives you 1, 2, and 3. I have chosen 2 since I want to expand my subnets to 2 AZs. How many subnets I want to have? I've mentioned 2. And then, do I need a NAT gateway? I said none. Do I need any VPC endpoint? I'm saying none because I am not running any S3 services as of now. DNS options, those are by default, they are already checked. So let's hit the create VPC. There were so many options available on the screen, hence I'm not sure whether you were able to visualize or not. So let's zoom it. What are the options I have chosen? So as I mentioned earlier, you are going to see 2 options, VPC only and VPC with subnets. The name for the VPC, it is going to be either auto-generated or you can put the name here. So I have given the name AJ-net, which you can see is being visualized here. My subnet is going to be 10.0.0.0/16. I don't have V6 CIDR block. My tenancy is going to be the default one. After the tenancy default, I have chosen, I want to expand my subnets to 3 regions. So you can see this 3 has been chosen, which you can see in the gray color, which also reflects here. I'm going to have 3 availability zones where I want to expand my subnets. So 1 VPC, 3 availability zone. First availability zone is going to be US is -1A, 1B is the second, and third is going to be 1C. Number of public subnets. How many public subnets you want to have? So I'm saying I want to have 3 subnets. So you can see my first subnet, second subnet, and third subnet. And those are going to be public in nature. To make it public in nature, I'm going to have a route table defined. Then it is asking how many private subnets you want. I don't want any private subnet for demo, so I have chosen 0. What is going to be first block on AG1? So it's going to be 10.0.0.0/20. Second block is going to be 10.0.16.0/20. That is going to be attached to 1B, which is going to be the second availability zone. And third is going to be 10.0.32.0/20, which is going to be attached to 1C. Now it is asking NAT gateway, and we will discuss NAT gateway in upcoming videos. As of now, I don't want any NAT gateway, so choose none. VPC endpoint, since no SC services I'm running, I have chosen none. These are the default options. Let's hit and create VPC. Once you hit, you can see create VPC workflow on your screen. So it is going to create all the components related to your VPC. Once your workflow is completed with a massive success, you can hit view VPC to see the resources. Let's take a look on the VPC what we created. So our VPC was AJ-net-VPC, and we can see the CIDR block which is assigned to this VPC is going to be 10.0.0.0/16. That you can also see here. There's a main network ACL. DNS resolution is enabled by default. DNS hostname is also enabled by default because we checked those 2 options while creating the VPC. And there's going to be main route table. Let's verify your VPC further. So on your screen, you can see there are two VPCs. One is going to be by default, which comes with your AWS account. Second one is something what we created. How we can verify these things. So CIDR block for default VPC is going to be 172.168.0.0/16. And if you take a look on default VPC, you can see this is the default one. And the one which we created, it comes with no. So that's something the resource is created by us. Now, when we take a look on the subnets, so hit the subnets, and you can see all these subnets. We defined three public subnets what we wanted to create. This is my first subnet, second, and the third. And rest of the subnets, those are created by default. You can also look at the CIDR blocks. What are the IP ranges associated? Let's verify route table. So you can see the option route table. These are the route table which comes by default. And this is a route table what we created. And why these route tables are needed? Because our three subnets, they are going to be public in nature. So you should have a default routes towards internet gateway. So I have three subnets. Those all are public in nature. So I'm going to associate this route table to all the subnets. How we can verify it? When we click on the route, so basically you need to click on this route ID, route table ID. It takes you to the next screen and you can see the routes. So I'm going to have a local route, which is you're going to be the CIDR range, and there's going to be default routes that's pointing towards your internet gateway. Let's go to the section security and go to the network ACLs. So by default, there are going to be the network ACLs associated. So for our three subnets, we can see there are going to be network ACLs with two inbound and two outbound rules. When you click on the network ACLs, you can see what are those rules. So for inbound rules, it is telling the rule number 100, type all traffic, protocol all, port range all, source all, and is allowed. Second is denied. Similarly, on the outbound, we can see rule number 100, all traffic, all protocol, port range is all, destination is going to be any, and that too is allowed. And last rule is going to be the deny. These ACLs can be modified. So whatever the traffic you want to restrict or you want to allow, you can create your own rules. Let's go back to route tables. And we can see this is a route table created by us. What if tomorrow you want to edit, delete, or modify something? So select it from here, from the checkbox, and go to the action, and then you can see those options are also available. Let's recap what we have done so far. So we created a VPC. Under that, we created subnet. Then you are going to have a route table to give access for all the resources sitting under the subnet to internet. You also need to create internet gateway and associate this route table to your subnet. And all these things we are going to see again when we do it automated way from Terraform. So for whatever the resources we provisioned, all the exercise that was all manual. There are multiple ways where you can use the automation to manage your resources on the cloud. So Terraform is going to be one of that particular tool, which is very famous when it comes to managing your resources on AWS. So you can use it from multiple platform. You can install Terraform your Windows machine, on your Linux machine, on your Mac OS, FreeBSD. There's so many options are available. I'm running a VM which is on Azure and running the Windows 11. Hence, I'm going to download this Terraform for Windows. And further, we are going to see whatever the exercise, what we have done manually, how we can automate that from the Terraform. So while downloading the Windows, it is going to ask you whether you want to go for 386 or AMD processor. Since my VM, I know it is running on AMD, I'm going to download this image. Once your image is downloaded, you need to extract it or maybe unzip it. So I created a folder which is Terraform inside my C drive. And there you can see this is terraform.exe. Now time to set up the environment variable. That is one of the system requirement. So in search bar, basically you can type environment and it will prompt you the system property. From there you can go to environment variable, and once you click on the environment variable you are going to see this thing. What we need to do, we need to add Terraform here under the path. So click on edit, click on new, and provide the path of where your terraform.exe resides, and then hit OK, and close all these windows. Now go to the directory where you kept your terraform.exe. This is under the Terraform folder, so cd terraform. And how to verify whether you have the correct version of Terraform which you want to use. So there's a command terraform-v. It is going to tell you that Terraform version 1.2.2 is on Windows AMD 64. There's another requirement to download another additional software is going to the Visual Studio Code, and it's very easy text editor and all the coding you can do it from here. So download it for Windows from code.visualstudio.com and go for the default configuration, which is going to be the next. So I accept the agreement and go for the next one until this is completed. Once your Visual Studio installation is done, you can launch that particular app and click here. This is going to download your extensions. In extensions, basically you need to search for Terraform. So if you put Terraform here, it is going to give you the multiple options. So please ensure you are downloading the extension, which is officially coming from HashiCorp, and then click install. All tooling requirement is completed. Now you need to create a working directory. So I'm going to create under my C drive a folder which is AWS projects, and under that there's a further folder AWS VPC. Now you can go to the files and open that particular folder from here, which is going to be your working project directory. Now you can see my project current working directory is AWS VPC. Any sort of provisioning for the resources you want to do on the AWS cloud, basically you need some sort of credentials. Those can be associated with the APIs called by Terraform. So from where those credentials comes, go to my account, and from there you see this option, access keys and secret keys. Click on that. If you don't have any keys created, you can hit create new keys, and make sure you download it because you're not going to see it again on the screen. So before we start provisioning the resource, couple of things you need to understand. Terraform is not just meant to support AWS. It does provide support to multi-vendors. So the file which you're going to create here under your working directory, make sure it has the extension TF. So I created a file. When you do the right click here under this section, so I created a file vpc.tf, and under that, this is going to be the working area where you want to do all the programming. So now I'm under the vpc.tf, and I want to do support to AWS. So my provider is going to be AWS. Once we mention AWS in the backend, it is going to download all the APIs required Terraform to perform all these tasks. Then you need to provide a reason. This is going to be US-is-1, where I want to provision my resource. Make sure you change it if you want to choose any other reason. This is equivalent to the North Virginia, what you see on your console. It's time to store access keys statically. Might not be the best practice. This is just for the lab purpose. So this is what we created from console. This is hidden because I don't want to share those keys, but it looks like that. So copy your access key, then copy paste your secret keys. And these credentials will be used along with the API to provision all the resources what you need. So right now, I'm going to provision only a resource, which is going to be AWS VPC. This is a name which is going to be the variable here. I'm just putting a name demo, and this is my CIDR block, which starts from 10.10.0.0/16. Now two commands I need to apply here. So this terminal, what you can see, you can run it directly from command prompt also. You can run it from the PowerShell. You can run it from the command line also. So this is the terminal option what you see on my screen. If you click here on the terminal, it is going to give you this command prompt here within the code, Visual Studio. The first command you want to run is going to be Terraform init. So it is going to initialize all these things, whatever the configuration you see on the screen. And then you need to apply Terraform Apply. So just replace init with apply. So once it is initialized, second is going to be the apply. Let's see how it looks. So you can see after doing the Terraform init, I run the command Terraform apply, and this command basically it is going to confirm or ask you for confirmation before it provisions any of the resources, and you can see those flows basically how many actions it is going to perform. So it is going to, so this is basically, you can say it's a kind of the review screen. What will happen once you commit these changes? So it is going to create your setter block. That is the only thing what we have mentioned here. And few things it is going to auto generate, and those will be known after the apply. Once your review is done, it is going to ask you whether you are sure you want to proceed. So enter the value yes, and then it is going to create all the resources. Now you can see the confirmation there. Apply completed, resources 1 added, 0 change, 0 destroyed. So this is successfully executed. Let's now verify on the console whether the resources you provisioned are created or not. So I can see this is the CIDR block I wanted to create, and it got created successfully. If you have noticed the previous screen, there was no name coming for that particular VPC, and the reason behind there was no tag attached. So in this exercise, I'm going to add a tag. The name is going to be the demo, And make sure before you do the init and apply the changes, you're going to save all the configurations. So go to the file, save all, and then Terraform init and Terraform apply, say yes, and this is done. So it has not added a new resource, but there's a one change for that particular resource what we created earlier. Since our change is completed, now we can see there's a name coming up for our VPC, which is going to be the demo, as we mentioned while provisioning it from the Terraform. Now our next requirement is to create the internet gateway. So let's verify on the portal how many internet gateways we have. So if you click on internet gateway, you can see there's a one gateway exist, and that is associated with VPC ID which ends with AA. And this AA is basically a default VPC which comes with AWS account. So in the next exercise, we are going to create our own gateway for a new VPC. While provisioning all these resources from Terraform, you need a reference of resource provisioning commands basically. So you can go to this portal, and under the AWS provider, you can see these components are available. So if you go to the VPC, if you go to the EC2, you're going to see all these commands given as a sample and the options available while provisioning those resources. Now, on the same existing script, we are going to add a internet gateway to provide internet connectivity to our subnets what we created. So this is going to be the additional command what you need to add here. Resource type is going to be the gateway. Name is going to be demo-gateway, and I'm going to give the same tag as well. And this is going to be associated to our original VPC, which was demo. Same actions you need to take: Terraform init, Terraform apply, and while applying these changes, you need to say yes. Now we see as an outcome, once this is successfully completed, there is one resource added, and that resource is going to be your internet gateway. Zero changes, zero destroyed. Let's quickly verify on the console. We can see the gateway what we added with the name of demo-gateway that exists now. Our next exercise is going to create a subnet. It's the same code we were done until here. Now we need to create a subnet which is going to be the public subnet. And before defining the public subnet, recall the concept of availability zone. So you need to pass this command: data AWS availability zone available state available. And then you need to provision a resource that is going to be AWS subnet. Name is going to be the public. It is associated with the same VPC ID, which is AWS VPC.demo. CIDR block. For this subnet, it is going to be the part of major block, which was /16. Now I want to configure this subnet with 10.10.10.0/24. And I'm going to choose a availability zone. And you can see there were three availability zones were available for North Virginia. So the numbering starts from 0, 1, 2. I have given 1 here so that it is going to choose 1B. Then tag is very important. So I'm giving the same tag. It's going to be the public subnet, and you need to do the same exercise. Start creating those resources from Terraform, init, apply, enter yes. And now I can see there's one more resource got provisioned, zero change, zero destroyed. It's time to verify the subnet what we provision from Terraform, whether that exists on the portal or not. So go to the subnets, and now I can see there's a one subnet which got created with the name of public. That's the tag which we have given. It has a CIDR value of 10.10.10.0/24, and it is provisioned for availability zone, which is going to be US-East-1B. Our final exercise is going to put a route towards the internet gateway what we created. So in the previous slide, we were done until a resource provisioning for the subnet until here. There's another resource which we need to add, and that resource is going to be basically AWS route table. That route table is named as demo-route. We can see in the tag. And what it is going to do, it is going to create a default route towards the internet for the CIDR 10.10.10.0/24. So you can mention your gateway ID, and this gateway ID we have given the name demo-ZW. Same exercise we need to do, and we can see the route got added. Let's verify under the route table. Now we can see this was a route which we added from the Terraform. Thank you for watching, and I will see you in the next video.